Alright, hello and welcome to this video on Git. Just a warning before we start. If you're a complete beginner at Git, this probably isn't the video for you. So bookmark this video and come back once you're kind of familiar with concepts like cloning repositories, pulling, pushing, and concepts like why you'd want to use source control. So this is a slightly more advanced video for someone who, say, is in the same situation that I was in a couple of years ago, or a similar situation that I've seen a lot of the junior developers that I've mentored over the years find themselves in, where they've graduated from university or they've graduated out of a boot camp, they've started their first software development job and then found themselves incredibly overwhelmed by their colleagues around them typing into a black and white terminal all day long, dealing with these scary things called commits, merges, merge conflicts, doing things like rebasing, and so on, right? So if that sounds like you, then this is probably the video for you. If you have absolutely no idea what I'm talking about, then you probably want to go and watch another video that kind of covers more raw basics of source control. Something like Git, Mercurial, or heck, even something like SVN would give you the underlying kind of knowledge that you'd need for this video. But yeah, if you feel like this video isn't for you, bookmark it and come back to it. But basically, to kind of summarize, I was once there. I was overwhelmed. And I made the mistake of wanting to learn Git. And obviously, it didn't take me long to realize that you can't learn Git. And I know that some of the junior developers that I've mentored over the past couple of years have run into the same problem, where you realize that Git is actually massive. It's incredibly complex. You know, you'll have one command that will probably have 10 different variations because of the different flags that you can set. And there's no way as a human being that you can memorize it all. So this video is going to revolve around what I believe to cover about 95% of the Git commands that you will probably need to know and understand to accomplish a day-to-day software development job, basically. So hopefully this video will be helpful. It's going to be following a course that I've kind of designed myself called Git Football Transfers, or soccer as it's called across the pond. Now, if you're not familiar with football or soccer, don't worry, you don't need to be. But what you do need to be familiar with are the key concepts of Git. So if you go down to the description, and on your way down to the description, you can click the like button and the subscribe button as well, you will get a GitHub repository. So the first thing that you want to do is clone the repository down. Now, again, this isn't the type of thing I want to be covering in this course, and if you don't know how to clone down a repository, this probably isn't the video for you, but you want to do git clone that URL, okay? And basically it is mentioned in the README of chapter 1. And the reason why I want to show you guys the GitHub repository is because I want you guys to use this GitHub repository as you follow this video as well. So you'll get knowledge from watching this video and visual knowledge by watching me do what you should be replicating, but you'll also get a lot of written help with diagrams from within the Git repository as well as at the end of every section there will be a summary of the commands that we kind of have covered within that chapter. So for example, chapter 1 is called visualizing a repository. As you can see, we've got a completely different readme where the git clone is covered, and yeah, so hopefully that's quite self-explanatory. The second prerequisite that I want you to do is to go to the Git repository and go to the main README and to look at this diagram and to read underneath. It's really important that you understand what things like the working directory, staging index, and your local repository is, as well as the difference between the local Git repository and the remote Git repository. The reason why it's important that you understand these concepts is because I'm going to be referring to these concepts throughout the video, and these concepts are referred to as well throughout the READMEs, whichever route you take to, you know, do this Git football transfers thing. And I think they're important concepts as well, because you know, some people, I've heard sometimes people say, well, I can just use something like SourceTree or GitHub Desktop as a GUI versus the terminal, which is all well and great. But if you don't, for example, conceptually understand concepts like the concepts covered here, or concepts like what on earth is the difference between a merge or a rebase, then it doesn't matter whether you're using a GUI or whether you are using the terminal. You still need to understand, you know, the underlying stuff that you are trying to do. You know, it doesn't matter whether you try and manually build a chair or whether you find some sort of machine that can build a chair. You need to know that a chair needs 4 legs in order to potentially hold up a human being, for example, right? That's probably the worst analogy known to mankind, but hopefully that makes sense. Okay, so let's kick off. Pun totally intended. So if we open chapter 1, obviously by this point I'm expecting that you've cloned the repository down, okay, and that you've got a terminal up and running within the root of the repository. So obviously we've covered this before. I said that I wouldn't teach it to you, but this is how you clone a repository, okay? Now, what is cloning a repository? What's that link that we put after git clone? That's pointing to a remote repository, right? It's pointing to a repository hosted over the internet, somewhere like GitHub, somewhere like Bitbucket, GitLab, etc. That we can point to, and we tell Git, yo, there's a repository on this URL, go and fetch it. The same way when we put google.com in our browser, you know, DNS magic happens, it resolves it to an IP address, and then our browser downloads the HTML and JavaScript and so on that we need in order to be able to display that website on the page. It's the exact same thing. Now, sometimes you do have scenarios where you may want more than what is called a remote, more than one remote on your repository. So if we at the moment here, bear in mind that this chapter is called Visualizing a Repository, we do git remote-v, we can see that our origin remote is referring to the GitHub remote repository, right? So sometimes you may want to add a secondary remote. This could be, for example, you might want to push to a GitHub repository, but you may also have a backup repository on Bitbucket for some strange reason. It sounds strange, but once upon a time, someone said to me, what happens if Trello goes down, which is where our Kanban board was based at the time, and we laughed it off and said, Trello's never going to go down, and Trello went down and no one had any idea what work they were doing. So, you know, in technology, anything is possible. So when you want to add a secondary remote, it will look something like this. Now I'll be copying and pasting sometimes commands because I have a mechanical keyboard and I don't want you guys to constantly hear clickety clack. Okay, so git remote add origin and then a URL. Now, kudos to you if you spotted that was wrong, because obviously we already have a remote called origin. We'd have got an error message saying, hold on a second, we already have a remote called origin, are you sure you want to call it that? So instead we'll call it test. And if we now do git remote-v, we can now see that our repository has an origin remote and a test remote. Fantastic. So if we now did git push test, it would then try and push our code changes in our repository to github.com/u/repo.git, right? Which obviously we're not going to do because it probably doesn't exist. Even though fair play to the person who's got the GitHub username u. Okay, so we've added test now. Now we want to remove test. So the way that we do that is git remote rm test. And if we now do that again, as we can see, we're back to where we started off, where we kicked things off with a git remote-v. Fantastic. So that is remote covered. Now this section is called Visualizing a Repository. And if you've ever used a program like SourceTree or Tortoise Git or GitHub Desktop and so on, you've probably seen the London Underground metro style diagrams. And they can be very overwhelming. And basically what they're trying to represent is the different branches within the repository and how they all come together through merges and so on. Trying to give you a visual representation of the history of a repository and the changes within a repository. And what you also get in these GUI programs are kind of lists of commits made by yourself or made by your teammates as well. So we can achieve something similar by just typing git log. Now I'm on a very low resolution here because of the nature of me recording and needing to zoom things in so that the text is big enough for you guys to be able to read it on the video. So in my case, I do git log and I only get the last 2 commits, but you guys on a much bigger resolution, bigger monitor, smaller font and so on, should probably get like the last 10 commits and so on. So this will hold us back a little bit on the video, but it shouldn't hold you guys back doing this alongside obviously me recording this video. So as we can see, the last 2 commits within the repository, one was made on Friday the 3rd of April by myself, and one was made on Thursday the 2nd of April. And the commit message for the first one was this, and the commit message for the second one was this. It's worth mentioning as well that our head is pointing at this commit. We'll talk more about our head in the later chapters, and that each commit comes with kind of like a GUID or an ID or a hash, as we'll call it, that is unique to that commit and represents that commit, allows us to refer to that commit. And we'll see an example of that in a bit. So for that reason, I'm going to go ahead and copy that And if you find yourself in this scenario where you've got a colon, you don't know how to exit, you just press Q and Bob's your uncle, right? So git log, it shows us a log of the commits in the repository, and we also spoke about that metro style of illustration, right? So this is how we can also replicate that within the terminal. So once again, git log, but we use the combination of three flags in this case: dash dash graph, dash dash decorate, dash dash one line. You can experiment with what happens by leaving those flags out. It's obviously not for this video at the moment. We're trying to be pragmatic and lean as possible. Again, you guys would probably get more commits listed than me on this lower resolution, but one thing you can see here is a secondary branch merging into the main master branch. There, of course, is the merge commit. So if this sounds like mumbo jumbo to you at this point, don't worry, because it will become clearer. But basically, what a merge is when you have the main branch of a repository and say a develop branch. So a developer will make their changes on the secondary branch, which initially starts off as a carbon copy of the main master branch that represents the code in production. They might make changes to that, and then once everyone's happy with those changes, they now need to replicate those changes on the main branch or the master branch so that those changes can be deployed into production or into live. So in order to do that, that secondary branch needs to be merged into the main branch. We'll look at this in more detail in a later chapter. And this is basically how it gets represented. You know, this is what creates these London Underground style of things, of illustrations, right? Where the secondary branch comes into the first branch with a merge commit. It's similar to what you get in GUIs, and you can replicate the same thing, obviously, in your terminal, which is quite cool because sometimes people prefer to be able to visualize something rather than just read text. There's also the git show command. So we copied, oopsie daisy, right? Okay, yeah, that's definitely not what we wanted. So if we go back and do a git log, we obviously wanted to copy this particular commit. So if we now do a git show and then the hash of that commit, as we can see, it is now basically displaying to us that commit whose hash we copied. Again, me as the author, same date and time, same message, but now it's actually telling us which files changed. And I do believe that if you do this on high resolution, what you will also see is green and red text, where the red text will represent anything that was removed from the file from its previous state via this commit, and the green stuff will be anything that was added to the file via this commit. So you'll be able to see how the file has changed on the back of the changes within this particular commit that we've referenced by the hash. And last but not least, obviously as developers, we all want to work in a non-blame culture. The team own the code base, not an individual. And you know, if a mistake happens, you work together as a team to fix it and then try and do an RCA to make sure whatever mistake doesn't happen again. It's never an individual, but sometimes, you know, you do want to know the history of a file in particular, and sometimes you want to be as concise as who changed what line of source code when in a specific file. So at the moment, we're in the root of our repository, and we have a readme.md. So if I do git blame readme.md, what it basically does is, if we look at the file, we see line 1, git football transfers, line 3, this repository. So if we look here, we have line 1, git football transfers, line 2, empty, line 3, this repository, etc. And next to it, we have references to commits. So what it's basically telling us is the last time this first line was changed was by myself on the 31st of March at this particular time in this commit. So we can now copy this. For example, I'm going to do a git show that commit to look at more detail as to maybe why that change was made. You know, there may be a little bit of an explanation in the commit message, for example, or the git diff that it runs. We might see more information that might make it more sensical as to why this line of code was changed. If we look at this line here, as we can see, this line was actually changed in a commit that happened about an hour later than this line was last changed. So, you know, quite simple. Hopefully that makes sense, and pretty much that kind of summarizes this first chapter. Hopefully you enjoy the first chapter. Hopefully you now feel like you're an expert on visualizing things via the terminal in a Git repository. And if you feel like, well, I've not really learned anything new here that I don't get for free in a GUI, I think that's a totally valid viewpoint. You know, I always run a mixture of, at the moment, I'm really liking GitHub Desktop, so I run GitHub Desktop and use that for like really simple stuff. And then I do things like rebases and stuff in the terminal and so on. So, again, this is meant to be a pragmatic course. So, yeah, hopefully you enjoyed that, and hopefully you'll stick around for the next couple of chapters. Okay, so second chapter that is titled Pulling and Checking Out Code. Now, again, I kind of emphasize that I kind of expect you to be familiar with these concepts, but we're building up to checking out, right? So if I now do git pull, I get a message that says I'm already up to date. And basically the reason behind that is because no one's made changes to the repository since I cloned it this morning and began to record, right? In a real life world where you've got teammates pulling and pushing to different branches, when you do a git pull, chances are you will pull new code down. And that may result in merge conflict or something along those lines, which we'll cover later on in the course. But basically what git pull does is it goes to the remote that we looked at earlier and says, yo, have you got any new code? If you do, I want to pull it down and integrate it into my local workspace, working directory. Okay, straightforward enough. So the reason why we wanted to cover that is because we want to basically start talking about the checkout command. And the reason why it's important that we understand the checkout command is because it's how we basically check out branches. So we covered branches slightly in the previous section, but let's just take a quick look at a slightly more visual representation of what a branch would look like. So we've got the master branch down here, which is basically a copy of the repository that represents the code currently in production or in live. Okay, I come along and want to implement a feature, but obviously I don't want to implement that feature slap bang on top of the master branch, because obviously that's risky. Okay, we won't say more than that. It's not really risky if you're mature enough and you do trunk-based development and you've got the right kind of DevOps practices in place, which totally, in my opinion, should, trunk-based development is awesome, but obviously we're not here to talk about trunk-based development. So a lot of places that are mature enough to kind of do trunk-based development, you'll have a feature branch. So it initially begins with my feature branch being a carbon copy of the master branch at this point. Okay, the master branch will change over time because my teammates are merging their own changes in, whilst I will continue to develop on top of that slightly older version of the master branch. Once my feature's done and it's been tested and it's been peer reviewed and everyone's happy with it, it then merges back into master, right? That's what we saw on the diagram earlier on, and it's what you see when you see all of these London Underground diagrams, right? So now the question is, when my teammate finishes working on his feature branch, how do I get that branch on my machine so that I can test it? And this is why the underlying knowledge is important for us to be able to start to talk about the git checkout command. So those of you guys that are more familiar with GitHub may have realized that there are two branches on our repository, which is called the La Liga branch. Now, if we look at the root of our repository, we've got a file called premierleague.txt. So if I now do git checkout La Liga, which is the name of a branch on this repository, as we can see, premierleague.txt is now been changed to laliga.txt. Previous file had current champions Manchester City. It has now been changed with current champions Barcelona, because the git checkout command has basically switched to the La Liga branch, which, as we know, can have very slightly different contents of the repository or the makeup of that repository, or very different, in terms of the makeup of that repository. It initially probably started off as a carbon copy of the master branch at the time, but then someone went off and made their own changes on the La Liga branch. Pretty straightforward, right? And we see this switch here in our terminal as well, where Bash kind of helps us and tells us, you're no longer on the master branch, you're now on the La Liga branch. So if I now do git pull, I'm going to get an already up-to-date message. But again, before, when we did a git pull, it was pulling down or looking for updates on the master branch. Now that we've switched over to the La Liga branch and we do a git pull, it is now looking for updates to pull on the La Liga branch. If we want to switch back to the master branch, we just do git checkout master. And as we can see, we're now back on the master branch. There's also a git switch command. So if you do git switch La Liga, I've got an older version of Git, so it won't work on my machine right now. I don't know why I have an older version of Git. This isn't my main development machine, that's why. yeah, git switch will also switch you between branches. And that is literally basically it for this second chapter. So hopefully you enjoyed that one. Okay, so we've reached chapter 3, which is all about pushing code. So if we look at the root of the directory, we have a Premier League.txt that says the current champions are Manchester City. Okay, so if we now use the git status command, it's basically telling us that our branch is up to date with origin/master. So if you guys remember, early on we did a git remote-v, and it basically told us that this GitHub repository is referred to as origin. So where we see references to origin/master, that means the master branch on the origin remote. In our case here, where we see on branch master or just master, that's referring to the master branch within our local Git repository. So origin/master is the master branch on our remote repository. Master on its own is the master branch on our local repository. And basically, obviously, we've made no changes. So obviously, it's basically telling us when we do git.status that the state of our local directory is the same as our remote directory. Okay, but we can change that. So how do we change that? If we change the current champions of the Premier League to Liverpool, and you know what? I like Italian football, so let's create a new file called serie.txt, and we now type git.status. We can see now that it's having a bit of a moan. It's telling us that the Premier League.txt file that our repository obviously knows about has been modified, and it's also telling us that serie.txt is an untracked file, and we see little M's and U's here in VS Code, which is why VS Code is awesome. And basically, when a file is untracked, that's basically our repository's way of saying, yo, I see a file in the working directory, but I've never heard of this file before, and you've not told me to pay attention to this file. So I'm going to tell you that I'm not currently tracking it. So obviously, until you add it to the staging area and then commit it, if you do a git push, it ain't going anywhere. Okay, so hopefully that makes sense. And let's just do a git diff. So git diff is going to ignore the serie.txt because again, it is still untracked, but what it's doing is telling us the difference now in state between our local working directory and basically our local repository. And what it's basically telling us in the red writing, it's saying before the Premier League.txt version in the repository, current champions are set as Manchester City. But in your local repository now, because you've modified the file, it's now set as Liverpool. Okay, and that's basically what a git diff does. So of course, as we saw, Serie A is untracked, so it actually tells us that we can use git add to track Serie A. And if you went onto the README and you did all the reading that I told you to read, you'll know that the git add command will basically bring files in from your working directory into the staging area. So that's what we're looking to do right now, and we can do that by doing git.add. The dot is kind of, especially like in the root of the repository here, is kind of like a wild card of saying anything that's new, just stage it in the staging index. However, we can also say serie.txt to add just that file specifically. And if I now clear this down, because I'm on a very low resolution to record this, and do git.status, we can see it's now no longer moding, and it's basically saying, thumbs up, there's a new file in this repository that you've added to the staging area, which means it can now commit to the local repository, and then that will allow us to push to the remote repository later on. So now we're at a stage where the changes that we've made have been staged or in the staging area, and we now want to commit them to the local repository. So doing that is quite easy. We can do git commit -m, where the M flag is basically saying this is the message we want to associate with the commit. If we don't do that, it will then open Vim. And if you don't know how to exit Vim, you probably should know how to exit Vim, or a text editor that you specified, like myself, Notepad++ or VS Code, where it'll open a file and say, please put your commit message here. Then you'll put your commit message there, close it, and then you'll know what your commit message is. So in our case, let's just say added Serie A and set Liverpool as Premier League champions, and boom. Okay, so if I now clear that and do a git status, your branch is ahead of origin master by 1 commit. So we've got nothing to commit because we've got nothing that's staged anymore. So what it's now telling us is that we've committed our changes into our local repository, but our local repository is ahead of our remote repository by 1 commit. Use git push. And that's basically telling us if you want your remote repository to be in line with your local repository, use git push to push the changes that we've just made to our remote repository. And then if we did git status again, it would look the same as what it did at the start of this section of the video. But unfortunately, it does actually turn out that we don't want to go ahead with these changes. Also, you shouldn't try git push at home because you won't be able to push to the repository because it's on my GitHub account. So that's the remote that's set unless you fork this repository onto your own GitHub account where you do have permissions. Okay, but yeah, so let's type a git log one line, and as we can see, here's our commit that we've just done on our local repository. But it turns out, and again here it's showing us that our remote repository is actually still at this previous commit, but it turns out that I want to reverse this. I don't know why I've added Serie A. Like, La Liga was a separate branch, right? Why have I added a Serie A.txt file to the root of this? I don't know. I'm being stupid. So let's do exactly that. And so the way that we do this is by doing a git reset. So the git reset, you have the hard flag, the mixed flag, and the soft flag. Now, chapter 5 is dedicated to the reset command. So we'll look at that in a little bit more detail. But building up to it, you'll probably get a rough idea of what it does by seeing what this does. So by running a git reset -- hard, the head with the little chevron thing is basically saying reset to the commit previous to where we're currently at. So if we now do git log one line again, we can see that the commit that we made has disappeared and our local master branch is now pointing back at this commit. Now this doesn't mean that the commit that we've reset away from goes away. It gets garbage collected, similar to how garbage collection works in Java or C#. Okay, I'm not going to go into more detail about that because we go into more detail about what happens with this kind of thing in chapter 5. But as a result of reverting or resetting, back to that previous commit, the reason why I don't want to say revert is because a revert is very different to a reset in Git. The Serie A.txt file has disappeared, and the Premier League.txt file has been reset to contain Manchester City as well. And if we do a git status, as we can see, it now says that we're in line with the origin master branch. Okay, cool. Also, just before we finish things off, let's change Manchester City back to Liverpool and do a git add and then do a git commit and say added loser pool. Okay, and do a git log one line. Oh no, it turns out we wrote loser pool. Okay, and someone's basically pulled us up about it and said, yo, make sure you're writing proper commit messages. So if we use a git commit -- amend flag, you might get Vim that'll open up. I've changed mine to be Notepad++, but if you do get Vim and you can't figure out how to exit Vim, you're a developer, so Google's your best friend. Figure it out yourself. Everyone's been there. It's your turn now. So yeah, I'm amending the commit message, change it to add Liverpool, close that. And if I now do git log one line, as we can see, the commit message has been changed. Okay, so in terms of commands you've learned this module, we've looked at status, git diff, difference between adding, to the staging index and committing to the local repository, what a git push does, and obviously we've looked at what a hard reset does and how you can use it in this kind of situation where you've committed changes and you actually don't want those changes anymore. If you're wondering, but that's not very useful because when I did a git reset hard, I lost all my changes. Sometimes I might just want to remove them out of the local repository and take them back to the staging index to make changes to them again. I don't want to lose them completely. That's where the mixed reset comes into the equation, and I promise you we will look at all of this in chapter 5. Okay, cool. So we've reached chapter 4. One thing worth mentioning as well that I should have mentioned really at the start of the video, but I didn't. We're only covering up to chapter 9 in this video. If you're interested in 10, 11, and 12, 12 is just a congratulations post. Again, you should be running this alongside the actual GitHub repository. So yeah, you can go and give them a read if you want to. Now, one thing as well worth mentioning is that from this chapter onwards, from 4 onwards, rather than working within the root of the repository, I want you to be working within the root of that chapter's directory, right? So in our case, I want to be working from inside of the for removing files and reverting commits. I've just realized there's two S's on the end of commits. So that's the folder that I want you to be working out of rather than the root, okay? So we've got a liverpool.txt and a Manchester City.txt, and basically, for those that aren't familiar with football, these are two different football teams, and they've got 3 players that play for those teams inside. So one thing I'm going to do is Chelsea is another team, and yeah, I'm not going to bother. Well, actually, let's put okay. We got Mason Mount, we got Abraham, and we've got the third player that popped into my head was Azpilicueta, and I'm just like, do I know how to spell Azpilicueta? Do I? Azpilicueta. I think that's how you spell it. Okay, so so if we now do a git status, we can see it's an untracked file. If we do a git add and do a git status, it now knows about the file chelsea.txt, which means it's now ready to be committed to our local git repository. But believe it or not, it actually turns out that we wanted to create a Manchester United.txt. The issue here is because we've already staged this file. If I now delete this file, we'd end up needing to do another git add because our repository will think it is missing a file. Okay? So the correct way for us to basically stop tracking the file is to stop caring about that file. Okay? So the way that we do that is using the git rm command that looks like this. So git rm -- cached and then the name of the file. So by doing that, it removes chelsea.txt. If I now do a git status, it is now untracked again. Okay, so just to show you what would have happened before. So if I now restart tracking that file and do a git status and now delete this file, it's now complaining. It's saying, you told me to track chelsea.txt, but that file's just been deleted because the repository is tracking that file, okay? The repository still cares about that file, even though it's been deleted. Versus when we did git rm, we basically told it, forget about this file. So there's quite a significant difference there. So it turns out we want to actually create a file called Manchester United.txt. I'm not going to waste time by adding players in. So we can git add and we can of course git commit with a message that says add Man United. So if we do a git log, as we can see, we now have a commit on our repository done right now called add Man United. Fantastic. Okay. Unfortunately though, it turns out that we want to now revert that change. So this is the difference between a revert and a reset, okay? You've already seen what a hard reset looks like, and you'll see what mixed and soft resets look like in the next section. A revert creates a revert commit. So what happens is, in our case, where we saw the git log, what it will do is, we will give it the hash of this commit and do git revert this hash, and what git then does is it looks at this commit and creates a new commit that reverses all the changes that were made within this commit. Okay, so hopefully you can start to see how that's quite different to a reset. So if I now do git revert that hash, it asks me, do I want the message on this revert commit to be called revert add Man United? Yes, that is fine with me. So as we can see, that has been reverted, which means the file has disappeared. But if we now do git log one line, rather than what we saw before with the reset, where the commit ceased to exist, we now have another commit. And if we look at the contents of that commit, it will contain the deletion of the addition of the Man United file, right? And likewise, if say this commit contained us changing Firmino to Eden Hazard, for example, and we committed that and we decided to revert that, the revert commit would be changing Eden Hazard back to Firmino. Pretty self-explanatory, pretty simple, but overall that's really the difference between a hard reset that we saw earlier and the git revert command. Okay, so it feels like a decade that we've been talking about resetting files. So let's just go into the folder we need to be within and actually start looking at resetting in a little bit more detail. So we're going to start off by looking at an example of the hard reset, which we have kind of already seen. So if we open liverpool.txt, it turns out that where journalists and users come in, that Liverpool want to sign Ronaldinho, which, you know, is, to be honest, quite cool. It turns out that we have some information as well about new Manchester United transfers, but we don't know about specific details yet. So if we run a git status, we've got an untracked file that is Manchester United and a modified file that's Liverpool, and we can obviously start tracking Man United by doing a git add, and there we go. You know, we've seen all this before, but unfortunately it does turn out that Ronaldinho retired a couple of years ago, believe it or not, and that the news that we received was false. So we want to completely undo all the changes that we've just made. So this is where we would do a git reset -- hard. So what it's basically done is, it's basically reset all the changes made within our staging area to match the state of the repository at that commit, at that point. Okay, you should be familiar with these concepts of commit hashes and so on right now. And obviously the revert add Man United is from the previous section because I didn't bother resetting the repository, which is fine. So one thing that's worth mentioning here is that if we open liverpool.txt, we've lost our change in this file completely. And we've lost the new file that we made completely. So you need to know that git reset hard is a destructive action. Okay, and one of the things I discussed at the end of either the last module before was whether or not you were thinking, well, what if I want to keep my changes? I just want them removed from the staging area. Okay, so we're going to look at that right now. So news has come in that Mbappe has signed for Liverpool. So what we'll do is we'll add Mbappe to liverpool.txt, and then of course we'll do a git add and then git status. We see that liverpool.txt has been modified, but actually news then comes in that Mbappe hasn't quite signed for Liverpool yet, but may do so in the next couple of hours. So we don't want to completely remove our change. We want to keep Mbappe in the liverpool.txt file in our local directory, but we just no longer want that change to be staged. So this is basically where we can do a git reset -- mixed, and we can see Mbappe is still in the file liverpool.txt, but if we do a git status, we can see that the stage is no longer, the change is no longer staged, right? The change only applies in our local directory. And you hear me say local directory and staging area and stuff a lot. This is the importance of why that thing in the main readme should have been read when I said so. Another thing you can do as well, so let's restage that change, which is obviously Mbappe in the file. You can just say git reset. So git reset without -- mixed is the same as git reset -- mixed. Okay, and last but not least, the git reset soft that we spoke about earlier, where you've got the head with the chevron, the head with the squiggly line, head squiggly line 2, and so on. So if we do git log -- one line, we can see here that we're currently pointing at fixed bug with chapter 8 readme. I got rid of those other commits, you know, with adding Manchester United and reverting Manchester United. But the question is, how did I do that? Believe it or not, using the git reset soft command. Let's say we no longer care about the changes that were made within this commit. We want to reset back to this, to basically, we want to set our working area and staging index to match the state of the local repository at this specific commit. So the way that we would go about doing that is with this command. So git reset -- soft, and then you can say either head with the chevron or head with the squiggly line. And what that is basically saying is, I want the head to now, I want to reset my working area and staging area to be equivalent to the commit that's one behind the current head. Okay, if we now say head 2, it will set it, can you guess, rather than to one behind the current head, the state that's 2 commits behind the current head, and so on. Okay, so an example of what that might look like is exactly that. So our state now is the state of the repository at that point, whilst before it was the state of the repository at this point. Okay, And the truth is, you probably won't use this very, very often at all. The ones that you'll find yourself using the most is probably just the normal git reset, which is mixed. You might from time to time find yourself using hard. I barely find myself using soft head. Okay, but hopefully that makes more sense. Okay, cool. So it's time for chapter 6. So again, CD back out, going to chapter 6, and if we take a look at Game of Thrones git log one line, I'm now back to where we were before doing those soft resets in the previous chapter. And if you're wondering how to do that, just do git pull. Because what it will then do is basically you're at this point in the repository, so by doing a git pull it will go obviously to GitHub and basically be like, oh look, we've got 2 more commits, and then pull them down and merge them in. So yeah, it's that easy. Okay, cool. So chapter 6 is about using the stash, and basically the stash is a storage area within a Git repository, and it basically exists to allow us to kind of like stash our current work in our working directory somewhere to one side so that we can come back to it later, right? Okay, it's not rocket science really. So we can create a new file called arsenal.txt, and if we run git stash include untracked, what it does is it now creates a new stash, and it tells us that it's saved the current state of the working directory in a work in progress thingamabob on the stash, and that's the hash for it that represents it. So as a result, arsenal.txt has been deleted because obviously what it's done is it's reset the state of our local directory back to what it was before we started making all of our changes. So right now, if I do git stash list, we can see our work in progress on master is here, and it has a stash ID of 0. So that is where our arsenal.txt is stored, or whatever changes we had at the time when we instigated the stash. So one thing that we can do is git stash apply 0, and boom. So we use 0 because 0 was the index of our changes within the stash, and as we can see, the arsenal.txt file has come back again. So this is really useful if you're in the middle of work but you don't want to stage that work yet, or commit that work yet and lose it. You can just stash it to one side really, and our arsenal.txt is back. So if we now look at our stash list, as you can see, even though we've restored the stash, we've not lost that stash yet. It's actually quite useful, but you might have scenarios where you do say want to get rid of a trillion things in your stash. So what you can do is you do git stash drop, and it's just told us there that it's basically gotten rid of that particular those particular changes that were stored within the stash, and that's basically it for using the stash. Really simple, really straightforward, and now we're going to be going on to the big boys that are merging and merge conflicts. Okay, so merging and merge conflicts. This is going to be fun. So let's take a look at this quick diagram. And again, this might feel like we've discussed this before because we have, but this is more of a kind of like graphical representation of what a merge would look like. You've got your master branch. You created a feature branch based off the master branch at that point. Your colleagues have committed twice to the master branch. It means that you've been making changes that don't incorporate these changes, which means that eventually when your feature branch has been peer reviewed and everyone's happy with that, you eventually want to reach a point where you can come back into the master branch so that you can incorporate your changes and you can all carry on with your lives and people can start committing on top, right? It represents the code saying production. That's kind of what it looks like visually, and that's where these London Underground type of graphical representations really stem from. Okay, so basically the TLDR is merging is when changes made to files on one branch need to be integrated or brought into another branch, okay? And the problem is that does sometimes result in merge conflicts. And basically a merge conflict comes about when 2 different developers make different changes to the same line of code, okay? We'll see an example of it as obviously we progress. So let's imagine we've got 2 reporters on football transfers, Alice and Bob. And Alice has basically received information that Paul Pogba, for some strange reason, is going to be joining Manchester City from Manchester United. So what we'll do is we will add Paul Pogba on line 4 of manchestercity.txt. Bob, meanwhile, on his own branch, receives news that Robert Lewandowski is basically going to be joining Manchester City. So Bob on his own computer will come in and then type Lewandowski, right? And then when basically, let's say Alice has merged the change with Pogba on line 4 into the master branch, and then Bob eventually comes along and wants to merge Lewandowski onto the master branch, he will get a merge conflict because it says, yo, Alice added Pogba on line 4. You're now trying to also add Lewandowski on line 4. Are you sure you want to do this, right? So, I mean, merge conflicts are looked at in negative light, but they're actually there to help us as developers. So let's try and simulate one now. So we're going to be Alice, right? And as we said, Alice is going to have her own branch. So the way that we can create a branch for Alice is by saying git checkout -b, which branch Alice. And yeah, we've switched to a new branch, Alice. Let's open Manchester City. Let's add Pogba. Cool. Let's stage our changes and let's commit our changes as Alice, obviously, where we say add Pogba to Man City. Cool. So if we now look at the state of the repository, the Alice branch is pointing at add Pogba to Man City, but our master branch obviously doesn't know anything about adding Pogba to Man City yet. Cool. Now we're Bob. So if we do git checkout if we do git checkout master, as we can see, Pogba's disappeared because Pogba doesn't exist on the master branch yet, and Bob has come along and wants to make his own branch. Okay, and he comes in and wants to add Lewandowski on line 4. We can do the exact same thing here, where add Lewandowski to Man City. Okay, so if we now do git log one line, we can see that the Bob branch now has add Lewandowski to Man City. Okay, so I'm now going to replicate that scenario that I said earlier. So for that reason, I am now apparently Alice, and we want to integrate Alice's branch into master. So if I now do git checkout master, I can now do git merge Alice, and there we go. So if we now look at git log one line, we see that master now incorporates the add Pogba to Man City commit. So Alice has been merged into master. And further proof that Alice's changes have been merged into master is that we now have on the master branch Pogba in manchestercity.txt. So if we now say, we've got, I think it was git branch, yeah, we've got master and La Liga still floating about, no, La Liga rather. We've got Alice and Bob. We now want to remove Alice's branch because we don't need it anymore. So we can do Alice branch, deleted Alice's branch. Okay, cool. So now Bob comes along and we need to merge in Bob's changes onto the master branch. So when we now do git merge Bob, it moans straight away. It says we've got a conflict because Bob is trying to put Lewandowski on line 4 of Manchester City, but Bob put Lewandowski on line 4 of Manchester City back when he checked out the master branch without containing anything on line 4. In the meantime, Alice has come along and put Pogba on line 4, right, which has basically led to this merge conflict. So now Bob needs to solve this merge conflict before he can actually commit properly to master. So what this is telling us here is it's telling us, or the contents of manchestercity.txt for the head pointer on master has Pogba. Obviously this would look a lot different if it was real code, and Bob's incoming change is trying to add Lewandowski. So it looks quite daunting, but it isn't really. All we have to do is try and manually fix it like that. So basically saying, yeah, okay, if someone's put Pogba on line 4, yeah, Bob decides I'll just put Lewandowski on line 5 then, and saves the file. And there are programs that help with this when dealing with source code like WinMerge and kdiff and so on. So at this point here, we need to resolve the merge conflict. So we believe at this point that we have solved the merge conflict. So we can write enter, and what we can do is git add and then do a commit that basically says fixed merge conflict. Okay, fantastic. If we now do a git status, okay, that's good. We do a git log one line. Cool. So there's Alice's commit. Bob has come in to obviously merge his changes in, and we now have a commit that represents the changes that were required to fix the merge conflict. Okay, and we're now at a point where we can do what we did with Alice, where we delete Bob's branch as well. Okay, so just there we simulated a merge conflict on a very, very small scale. Just before we go on to the next section, I want to highlight another thing that I don't think I explained very well. So basically, when we merged Alice in to the master branch, we skipped over the fact that it said fast forward. Now, sometimes what Git does under the hood is do something called a fast forward merge, and that always kicks in, like in our case, where Alice's changes of adding Pogba to line 4 weren't going to be met with any merge conflicts. So Git basically merges the changes in such a way where you can avoid needing that extra commit for the merge. Now, when Bob came in, there was a merge conflict. So with this kind of scenario, you not only have Bob's commit, but you also have an extra commit that is a fixing of the merge conflict. And the reason why I say we need to bear this in mind is because we're going to be looking at rebasing in the next section. All right, we are almost there. Chapter 8. Now, one thing worth mentioning is that I have reset things back to, where the repository should be at, which means all the changes that obviously we made with the merging and so on have gone. It's up to you to figure out how on earth you go about doing that. You should know that by now. I'll give you a clue. It's the reset command, and we covered it in a bit of detail to get back to that point. So what I'd recommend is type git log --1 line, look at the changes we made in chapter 7, and figure out how you can get back to fix bug with chapter 8 readme. So let's go back and into our rebasing folder, and let's show you some diagrams again. So the difference between a merge and a rebase. So we saw the previous diagram for the merge where we had the feature branch, and then eventually when a merge conflict occurs, you end up with this branch coming back in to merge, and then a commit that deals with the merge conflict. Rebasing aims to solve the same problem that merging does, but in a different way. So in the same scenario, this is our master branch and this is our feature branch. We reach a point where we want to bring our changes from the feature branch into the master branch. So we'd get a merge conflict, we would solve that merge conflict, we'd get a new commit that would represent the merging of feature branch into master, and then we would carry on with our lives. With rebasing, what we do is actually go to the latest version of master and then try and replay all the changes on our feature branch on top of the latest version of master. So no merge is involved. We literally replay these changes on top of master in its current updated state. And we go and replay through each commit one by one manually. And what that does is it avoids this London Underground style of merge, and it makes our kind of repository look like everything was perfectly done sequentially, okay? Even though development was actually happening simultaneously. So literally it's a case of, I want to merge in, rather than try and merge in and end up with a merge commit that solves the differences between the state of this branch and this branch, we instead just try and pretend we're trying to replay our feature branch on top of our master branch to make it look a little bit more like this and avoid the merge scenario. Let's simulate a rebase. So how are we going to go about simulating a rebase? So good news for you guys is that, I don't know why I just typed clear there, is that we're going to do the exact same thing that we did in the previous section. Okay, so I'm Alice again. I'm now on the Alice branch. I've received news that Manchester City have signed Eden Hazard. Okay, cool. So git add and then git commit add Hazard to Man City, Cool. And I've also received news that Messi has signed for Manchester City. So if I now do git add and then do git commit, add Messi to Man City. Cool. So if we take a look at what the Alice branch currently looks like, okay, yeah, there are 2 new commits on Alice's feature branch. Cool. So let's go back to master, and now we're going to be Bob. So we are now Bob, and Bob has received news that Suarez has joined Manchester City. Okay, again, notice that Hazard and Messi are no longer on this file because we checked out master and then made Bob's branch off master, and obviously those changes of Messi and Hazard only exist on Alice's branch. We want to add Suarez, so we'll do a git add and then a message, and then we'll say add Suarez to Man City. Fantastic. Okay, so if we now do a git log 1 line again, we can see that Bob has added Suarez to Man City. Okay, so now Bob this time is going to merge his changes into master first. So let's go to master and then do git merge Bob. And again, we've had this similar fast forward scenario where on master now, if we do git log 1 line, because there was no merge conflict, we don't have an extra commit to deal with the merge conflict. It does this thing called a fast forward merge. And it now means that we can obviously get rid of the branch, because Bob's branch is no longer needed. So we can double check that by doing git branch. Okay, Alice's branch is still there. And now we're at a point where Alice finally decides that it's time to rebase her changes onto master. So we've switched to Alice's branch, and as Alice we've got Hazard and Messi, and you can probably already spot where we're going to end up 100% with a conflict, which is again line 4, because Alice has put Hazard on line 4, and obviously now the state of master has changed, has been updated to have Suarez on line 4. So as Alice, we will do git rebase master, and what this is doing here is on Alice's branch, she's going to try and basically rebase her changes on top of master. She's going to take the current state of master and try and rewind and replay those last 2 commits that Alice made on top of master, on top of the current state of master. And here we go. Okay, so let's take a look at this. Rewinding ahead to replay a work on top of it, applying add Hazard to Man City. So the first change that Alice made was adding Hazard to Man City, and this is the conflict we spoke about. Suarez is now on line 4 in master, but Alice wants to put Hazard on line 4. So the same way we solved the merge conflict before, we will solve this one here. So Suarez will remain on line 4, Hazard will remain on line 5. You may have noticed that this will also cause, well, firstly, you should have noticed that Hazard is there, however, Messi isn't. Secondly, you should have noticed that the reason behind that is because when you rebase, we're going through Alice's commits one by one. So we're going through the Hazard commit first. Because remember, we committed Hazard and then we committed Messi. So we've replayed the Hazard commit, and you should now also notice that Alice put Messi on line 5, which means when we replay Alice's next commit, we're going to have another merge problem. So it says failed to merge in the changes. We need to solve these changes, which we have done. And once basically we're happy with what we've done, we do a git add, and then we do a git rebase -- continue. As you can see, we're on branch Alice, and it's telling us we're trying to do a rebase, and we're on the first of 2 potential rebases. So git rebase -- continue, and we're now replaying the add Messi to Man City commit on top of the state of the last rebase. So that's why we've got Hazard here and Hazard here. So the state of the last rebase added Hazard to line 5, but we can't now add Messi to line 5 because Hazard is there. So fortunately for us, this is quite a simple change. And it also emphasizes the importance as a developer of having small commits. Even though I am yet to work in a team that wants to actively use rebasing, and teams that I've worked in, for example, that don't do trunk-based development use Git flow, and rebasing is frowned upon in Git flow. If you're going to rebase, you should only be doing it on a non-shared branch, which is something we'll cover very shortly. So we've added Messy to line 6 now as part of this rebase. We've applied, solved the merge conflict when trying to apply that specific Messy commit. So what we can do as well, again, is git add and then do a git rebase continue. And just like that, we should be happy. Okay, so what has now happened on Alice's branch is we've updated Alice's branch with the latest version of master and tried to replay all the changes that Alice made on top. So now the state of Alice's branch should literally be equivalent to master plus Alice's changes, as if Alice has literally just done those changes on top of the new version of master. Because when Alice first checked out master, master looked different. It was before Bob merged his changes in. So now the job's not done. Alice's branch is now in a state where it should be able to merge into master quite easily, because again, Alice replayed and rebased her changes right on top of the current state of master. So in theory, there should be no merge conflicts at all. So in this case, let's give that a go. We're now back at master. Only Suarez is in there, which is Bob's change, and we should be able to do git merge Alice. Whew, that was that was an interesting one. Okay, so we can now do git branch d Alice. So if we now do git branch, we're left with La Liga and master, and the current state of master is that we've incorporated Bob's changes, and Alice's changes are now there as well, that have been accomplished through rebasing. Okay, so the golden rule. So I'm not going to go into too much detail about the golden rule. The TLDR is never rebase onto shared branches. Okay, only rebase on a branch if you are the only person working on that branch. Okay, I'm not going to go into details. That is what the GitHub README is for, and that is what Google is for. And so yeah, you know what to do from here. Yeah, that is literally it for chapter 8. Next chapter, final chapter, we're going to start rewriting some history and start to see what on earth an interactive rebase is. That's assuming your mind hasn't already been blown around rebases already. Okay, so again, using the git reset command, I've now got the repository back at a stage that represents the one that, you know, is on origin master. So again, you should know how to do that by now. And proof of that is if we look at this manchestercity.txt that we were using for rebasing and stuff in the last chapter, it's now back to Aguero, Laporte, and Edison. So what we want to do is obviously step into chapter 9. So this chapter is called Refactoring History with the Interactive Rebase. And basically sometimes as a developer, you make mistakes, right? So what happens is you should be looking to try and commit frequently and often, but that tends to mean you're sometimes committing mistakes, right? Because you might do a tweak in one little area of the code that at the time was correct and made sense. So you commit that, but then later on as you start bringing in different components, you realize that, oh no, you did the wrong thing, okay? And you want to hide that from your commit history and whatnot. So basically the interactive rebase on a local branch is kind of like a user-friendly way that allows you to refactor your commit history. So we're going to see an example of that. Okay, so with the interactive rebase. Cool. We're on our master branch. That's irrelevant at the moment. And let's just assume that we want to create a new file called arsenal.txt. We're trying to mimic a real development workflow locally. Now, loads of small commits when you're developing is great, because if you mess up, and you need to revert to a previous commit, you're not reverting the whole world. You know what I mean? If your commits are really big, then you've got to look at your commit history, figure out what was changed, and then manually change it around, because if you revert, then you're going to lose too much work. But when it comes to actually being done and wanting to push your code up and having peer reviews and stuff, you don't necessarily want 40 plus commits, right? So you might find that some of the work that you've done can actually all be merged into, all be squashed, into a single single commit. When you do that, you might want to reword the commit message and so on. And this is what the interactive rebase allows us to do. So let's try and mimic developing locally. So I've created an arsenal.txt file. We'll add it and we'll do git commit message added arsenal file. Fantastic. So let's add a couple of historical players in here. So we'll do git commit added Thierry Henry, and then we'll say Perez. We'll say git commit added Perez, and then Vieira, and do git commit added Vieira. Whoops, forgot to do a git add. Cool, fantastic. That's the state that we're at right now. So if we now push up to GitHub, we will be pushing 1, 2, 3, 4 commits. Now we're dev done here and we're happy with what we've got. And we've decided our commits were actually a bit too concise. So this is where the interactive rebase comes in. So the way you can do this is by typing git rebase and then doing -- interactive, or just basically a single dash with the I flag. And this is where Vim will open for you, or whatever editor that you've got. So I want the addition of Vieira and the addition of Perez to be squashed into this one commit. So what we can do here is either write squash or write S, right? And basically it will know that obviously the commit that these two are going to be squashed into is going to be this commit, right? Okay, added Henry won't be squashed into added Arsenal file, but added Perez and added Vieira will be squashed into added Henry. So happy with that. Save that, okay, and close that. And what it's then just done in the background is try to rebase, as we did in the previous section, the change of adding Vieira and the change of adding Perez. Now in our case, we're adding on the second line and the third line of the same file, so we don't get a merge conflict, but you can quickly start to see that merge conflict could become a problem here as well. Now the only real message that we're bothered about to change here, because added Vieira and added Perez we know are going to be squashed into added Henry, so what we can do is say, instead of that commit obviously being just added Henry, it should be added Henry, Perez and Vieira, right? So we can do that, we can save that and close that, and it says that we've successfully rebased. So if we now do git log one line, we now see we no longer have 4 commits. Those 3 commits have now been squashed into 1. So if we now do a git push, only 1 commit will go up. So that is basically it for this pragmatic video on Git. Hopefully in this video I've kind of covered like 95% of what I use day in, day out, and what you would probably need to use day in, day out. And again, you should focus less on making sure you memorize the commands and more making sure on you understand what is possible, so that when you find yourself in a scenario where you need one of these things as a solution to a problem, you're able to go, aha, I know I can do this in Git. I don't remember the command to do it, or I don't remember how to do it via GUI, but I know it exists. So you can go away and Google how to do it and then do it. It's like development, right? Like you don't always remember how to do specific things, or you don't always remember the syntax of how to do specific things. But you know that it can be done, what you want to do, and you know that it exists, and therefore you know you can go to Stack Overflow or to Google and see how it's done there and then. So focus on concepts with Git especially, not on trying to learn all of Git, because you'll be here all day, and to be fair with the state of this video, we've been here for like an hour at least, I think. So yeah, hopefully you enjoyed it, and if you did enjoy the video, please press the like button, subscribe to the channel. This is the first video I've ever made of this kind of like tutorial style nature in software development. I'm aware that some of the teaching maybe could have been a little bit better, and if there were areas that you felt like I didn't explain very well, please feel free to let me know that feedback in the comments below. And that is going to be it from myself. So thanks for watching.